Oh, this is Scholar Draft doing some math today in Algebra 2. We're looking at combinations. Last time we looked at permutations, and it mattered whether uh, order did matter in your group of objects. In combinations, we take a selection of objects from a group where order is not important, and it's denoted as NCR, where n factorial over n minus r factorial times r factorial. So let's look at a deck of cards. We have 13 clubs, 13 spades, 13 hearts, and 13 diamonds. So we have 52 total. The clubs are black, spades are black, hearts are red, and diamonds are red. So we have 26 red cards and 26 black cards. If the order in which the cards are dealt is not important, how many different five-card hands are possible? So out of the 52, we're going to choose 5. So we're going to deal out 5 cards, and we're going to see how many different type of hands we could have. So 52 factorial over 52 minus 5 factorial times r factorial, which is 5 factorial. So we have 52 factorial, which is 52 times 51 times 50 times 49 times 48 times 47 factorial. On the bottom we have 47 factorial times 5 factorial. 47 factorials go away. So we're left with 5 times 4 times 3 times 2 times 1 on the bottom. On the top we have 52 times 51 times 50 times 49 times 48, and that'll give me 2,598,960 different hands. And how many 5-card hands are all 5 cards of the same color? Okay, so we're going to combine the fundamental counting principle with our combinations. Okay, so we take the number of color combinations times the number of card combinations. So out of the 2 colors, we're going to choose 1. And out of the 26 cards in that color, we're going to choose 5. Because we're looking for how many 5-card hands are all 5 cards the same color. So this will equal to, so 2 choose 1, so this is the colors, so 2 factorial over 2 minus 1 factorial times 1 factorial times 26 factorial over 26 minus 5 factorial times 5 factorial. So the first one is just 2, because 2 over 1 is 2. And then the second one is 26 times 25 times dot 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 to 21 factorial over 21 factorial 5 factorial. So that'll equal to 131,560. How many 5-card hands can be dealt if there's at least one diamond? Okay, so this is the total number of hands minus any hand with no diamonds. Diamonds. Okay, the total number of hands is 52, choose 5. And we already figured that out in part A. And then we're going to subtract all the possible combinations where there's no diamond. So since there's only 13 diamonds, we're going to take 52 minus 13, which is 39. So 39, choose 5. So we know that from part A, 52, the total number of possible combinations is 2,598,960. We're going to subtract all the combinations where there's no diamonds. So that's 39 factorial over 39 minus 5, 5 factorial. So this would be 2,598,960 minus 57,000 or 575,757, which will give us 2,023,203 hands. How many 5-card hands can be dealt if there are 5 hearts or 5 spades? Okay, so all 5 cards have to be hearts or spades. So we want to know, out of the 13 hearts, we're going to choose 5 of them, plus 13, choose 5. So this first one counts for the 5 hearts, and the second one counts for 5 spades. So out of all the 5-card hands, how many of there are 5 hearts or 5 spades? So again, this is 13 factorial over 13 minus 5 factorial over 5 factorial. And this will equal 1287. So 1287 times 2, or 1287 plus 1287, is 2,574 hands. William Shakespeare wrote 38 plays that can be divided into 3 genres. Of the 38 plays, 18 are comedies, 10 are histories, and 10 are tragedies. How many different sets of exactly 2 comedies and 1 tragedy can you read? So out of the 18 comedies, we're going to choose 2. And out of the 10 tragedies, we choose 1. Okay, and then your calculator also has this function. If you're using probably one of the higher TI-84, you would use... So in my calculator, there's a math button, and then you can go to probability. And in the probability, you'll see NCR. So you would punch in 18, then the NCR, and then the R, which would be 2 in this case. And that'll give you 153. Or, once again, this is 18 factorial over 18 minus 2 factorial, 2 factorial. And 10 choose 1 is just 10. So we multiply these together, and that'll equal 1,530 sets. How many different sets of at most 3 plays can you read? So what this is saying is you can either read 0 plays, or you could read 1 play, or you can choose 2 plays, or you can choose 3 plays, and we want to know how many different sets, how many different combinations can you do. So we're going to take 38, choose 0, plus 38, choose 1, plus the number of combinations for choosing 2, and plus the number of combinations for choosing 3 plays. So there is only one time where you can choose nothing. If you wanted to choose one of the 38 plays, that'd be 38 different choices there. If you're choosing 2 different ways, the combinations could be 703. And if you're choosing 3, 8,436. Add these all up, and you get a total of 9,178 sets. Part D. You're picking up 7 books from a stack of 32. If the order of the books you choose is not important, how many different 7 book groups are possible? That would be 32, choose 7. And just to make sure, this is 32 factorial over 32 factorial, or 32 minus 7 factorial, 7 factorial. 32 times 31 times 30 times 29 times 28 times 27 times 26 times 25 factorial over 25 factorial, and 7 factorial becomes 7 times 6 times 5 times 4 times 3 times 2 times 1. So that is 3,365,856 different book groups. Popular magazine has 11 articles. You want to read at least 2 of the articles. How many different combinations of articles can you read? So at least 2. Okay, we want to read at least 2. So that could be 3 or 4. We could read 5. We could read 6. We could read 7. So we could say the number of combinations for 2 plus the number of combinations for 3 plus the number of combinations for 4, 5, 6, 7, 8, 9, 10, 11. Or we could say we can do the combinations of all articles minus reading 1 or 0, because that'll give us everything else. Because we want to know the combinations for at least 2 articles, so we can just take all the articles, all the possible combination articles, and just subtract reading 1 or 0. So this is 2 to the 11, because this is just, all articles. Okay, so for the total number of articles, how do we figure out that? Well, we either read an article or we don't. So for each article, we have a choice, yes or no, to reading it. So since there's 11 articles, this is 2 to the 11 combinations, 2 to the 11th. Minus, if we only read one article, which would be out of the 11 articles, we choose 1, plus or we read 0 articles, 11 choose 0. So 2 to the 11 is 2048. Represents the number of articles, number of combinations of articles that we read, that decided to read, minus, if we chose one article, there's only 11, plus the number of articles, or the number of combinations where we can choose 0. There's only one it's only one time. So 2048 minus 12 equals 2036 combinations. Your school football team has 10 scheduled games for the season. You want to attend at least 4 games. How many different combinations of games can you attend? So this is very similar. Instead of doing choosing 4 games and add the combinations of 5, choosing 5 games, combinations of 6 games, 7 games, 8 games, 9 games, 10 games, we're just going to do all games. So the number of combinations for choosing all games minus attending 0, then 1, then 2, then 3 games. So we either have 2 choices for attending a game. We'll either redo it or we don't. So the combinations are 2 to the 10th minus the number of combinations if we chose 0 games, plus the number of combinations for choosing 1 game, number of combinations for choosing 2 games, 3 games. Okay, so this is 1024 minus 1 plus 10 plus 45 plus 120. So there is 848 different combinations for attending these football games. Hopefully this helped you out. Have a good day.